In this video, we're going to talk about another method of integration, namely the partial fraction decomposition. Every polynomial can be factored as a product of linear and or quadratic factors. As an example, let's say we have x cubed plus x. Let's factor the x out. We get x times x squared plus 1. X is a linear factor, and x squared plus 1, this is a quadratic factor. Every rational function of the form f of x is equal to p of x divided by q of x, where the degree of p of x is less than degree of q of x, can be decomposed into partial fractions. It's important to note that p of x is a polynomial, and so is q of x, the denominator. That's also a polynomial. Alright, so let's say we have f of x is equal to 3x minus 1 divided by x squared minus 1. What is p of x? Well, p of x is a numerator. That is 3x minus 1. What is the degree of this polynomial? Well, the degree is going to be just 1 because it's x to the power of 1. So the degree of p of x is equal to 1. What about the denominator, q of x? Q of x is x squared minus 1. What is the degree of this polynomial? The degree is 2 because we have x squared. So the degree of q of x is equal to 2. Now we note that the degree of the numerator, p of x, is less than degree of the denominator, q of x. 1 is less than 2. So we apply partial fraction decomposition. Let's start with f of x is equal to 1 over x minus 1 plus 2 over x plus 1. Let's add these two fractions. So I'm going to multiply top and bottom of the first fraction by x plus 1 over x plus 1 to create a common denominator. And the second fraction, we multiply top and bottom by x minus 1 divided by x minus 1. We now have a common denominator, so we can add the numerators. So we get x minus 1 times x plus 1, and in the numerator we will get x plus 1 plus 2 times x minus 1. So what we have is f of x is equal to x plus 1 plus 2 times x minus 1 divided by x minus 1 times x plus 1. That's equal to 3x minus 1. If we simplify the numerator, 3x minus 1 divided by x minus 1 times x plus 1. Now the goal of partial fractions is to reverse this process. The process of addition of fractions, we want to reverse this process. So 1 over x minus 1 plus 2 over x plus 1, we added these two fractions by creating a common denominator, and we got 3x minus 1 divided by x squared minus 1. Now the goal is to reverse this process. 3x minus 1 divided by x squared minus 1, that's equal to, the first thing you do is you factorize the denominator as a product of linear factors. So we get 3x minus 1 divided by x minus 1 times x plus 1. And we write this as a over x minus 1 plus b over x plus 1. Now, how do we find a and b? That's the big question that we have to ask ourselves. All right, so we have a rational function, say 3x minus 1 divided by x squared minus 1. And our goal is to apply partial fraction decomposition and rewrite this as a over x minus 1 plus b over x plus 1. So you can see that this is going to be hard to integrate. 3x minus 1 divided by x squared minus 1. This is difficult to integrate. But we can see that if we decompose a fraction a over x minus 1 plus b over x plus 1 dx. This will be easy to integrate. So again, how do we find a and b? So we have 3x minus 1 divided by x squared minus 1. We decompose this. Well, first we should factorize the denominator. We have 3x minus 1 divided by x minus 1 times x plus 1. This is equal to a over x minus 1 plus b over x plus 1. Alright, so we have 3x minus 1 divided by x minus 1 times x plus 1 is equal to a over x minus 1 plus b over x plus 1. The strategy will be to multiply both sides by the denominator x minus 1 times x plus 1 so we can clear out the fractions. Alright, so what we have is 3x minus 1 divided by x minus 1 times x plus 1. We applied partial fraction decomposition, and we get a over x minus 1 plus b over x plus 1. We clear out the fractions by multiplying both sides of this equation by x minus 1 times x plus 1. When we do that, we will obtain 3x minus 1 is equal to a times x plus 1 plus b times x minus 1. Alright, so now what we do is we basically collect equal powers of x. So we have 3x minus 1 is equal to a plus b if we collect all the powers of x, and if we collect all the constant coefficients, we get a minus b. And this is just basically algebra. Alright, so now we can see that if you look at the left-hand side, the coefficient of x is 3. If you look at the right-hand side, the coefficient of x is a plus b. And again, if you look at the left-hand side, the constant coefficient is negative 1. If you look at the right-hand side, the constant coefficient is a minus b. So equating the powers of x on both sides, we get 3 is equal to a plus b. Equating the constant coefficients on both sides, x to the 0, which is just 1, we get negative 1 is equal to a minus b. Now from the first equation, we will solve for a. We get a is equal to 3 minus b, and plug this into the second equation. So we get negative 1 is equal to a is 3 minus b, and we get negative 1 is equal to 3 minus 2b. And solving for b, we will get minus 4 equals minus 2b, and divide by minus 2, we will get b is equal to 2. And let's go back to the expression we had for a, this expression. A is equal to 3 minus b, and we will get a is equal to 3 minus 2 is equal to 1. So now we have a is equal to 1, b is equal to 2. Alright, so what we have shown is that 3x minus 1 divided by x minus 1 times x plus 1 is equal to 1 over x minus 1 plus 2 over x plus 1. So this part here, this is what we had for a. We solved for a, and this part is b. Alright, so now we're able to integrate. So we have integral 3x minus 1 divided by x minus 1 times x plus 1 integrated with respect to x. We applied partial fraction decomposition and we solved for a and b, and we got 1 over x minus 1 plus 2 over x plus 1. Now we integrate term by term. What is the integral of 1 over x minus 1? Well, that's going to be log of x minus 1. What is the integral of 2 over x plus 1? That's going to be 2 times log of x plus 1 plus the constant c. So what we have shown is that the integral of 3x minus 1 divided by x squared minus 1 dx, we applied partial fraction technique, and we obtained log of x minus 1 plus 2 times log of x plus 1 plus c. Now, let's talk a little bit more about the integrations that we applied. So, for example, if you have integral of 1 over x dx, what is the antiderivative of 1 over x? Well, that's just going to be log of absolute value of x. What is the integral of 1 over x squared plus 1? We didn't apply this integral in this question, in this video, but in the upcoming videos, we will be applying this. So what is the antiderivative of 1 over x squared plus 1? That is tan minus 1x plus c. What is the integral of 1 over x plus 1? This is going to be log of absolute value of x plus 1 plus c. We're really applying the substitution rule here. We're letting u be equal to x plus 1, and du is dx. The derivative of x is just 1. So more generally, we have integral 1 over ax plus b. We have a linear factor in the denominator. This is going to be equal to log of absolute value of ax plus b divided by a plus c. Why do we divide by a? That's because of the substitution technique. We're letting u be equal to ax plus b. Take the derivative of both sides, we get du is a dx. Divide by a both sides, we get dx is du over a. The reason we divide by a here is exactly the reason we divide by a here. Let's look at another example. What is the integral of 1 over 2x plus 1 dx? This will be log of absolute value of 2x plus 1 divided by 2 plus c. Because we're letting u be equal to the denominator 2x plus 1. Take the derivative, du is 2 dx. Solve for dx. Dx is equal to du over 2. And the reason we have a 2 here is precisely the reason we have a 2 here. All right. Thank you.